Yeah.
Exactly. Thank you so much for the introduction, Nancy. I'll take over and talk a bit about how we are building LocalStack with LocalStack. So before we get started, I'll jump right in and talk about the software development lifecycle that LocalStack wants to support from start to finish. So typically that starts on the developer machine with local development and testing, moving on to CI pipelines where you can run your integration test suites. Now, a new feature that's been released with 3.0, which will enable acceptance and end-to-end tests. And last but not least, everything is moving to production, to the real environment. So now the question is, how are we doing all of these things at LocalStack? Well, we are using LocalStack to build the LocalStack Web Application, which means that if you're not familiar with the screenshot on the right, it's a web application which allows you to create your LocalStack account, get your LocalStack subscription, and then do and use Cloud Dev tools on the web app. For example, we have the resource browser on the web application. We have tools around chaos engineering and policy streaming. You can manage extensions from the UI, and you can also interact with Cloud Pods, like inject them into your running LocalStack instance or create a new one from the currently running one. So how do we manage to use LocalStack for that? Well, let's take a top-down view at our application. Our web application is comprised of two components, which are here on the right-hand side in the boxes. On the left-hand side, we have the web application. The web application is your run-of-the-mill React application, which is served through Route 53, CloudFront, and S3. And then, as all newer web applications, you have an associated or related backend. And our backend is implemented in Python, and we are using Flask for the API itself. And among those, we also use various services. So we don't only have a Flask application, but we also make use of AWS services like Lambda, SNS, SQS. We use S3 buckets for storage. We use Cognito for user management. We use EC2 and ECS as well for serverless resources. And then DynamoDB for storage and Secrets Manager for secret storage. So how do we use that or with LocalStack? Well, let's start with the first step here. Let's keep it simple and small. Local dev and testing. Where does LocalStack help us with developing the backend? And on the left-hand side, I have listed all the various things which we will talk and go through. First is Boto3 configuration. Then we'll take a short look at development and testing. Deployment and testing. Then we'll look at development and debugging. We will see how we use LocalStack extensions. And then last but not least, how we use Cloud Pods to enable local dev and testing. So baby steps. Boto3 configuration. What is it? Why do we need it? Well, at the heart of our backend, we have a Python Flask application, which in production should talk to the real AWS cloud, and during development, talk to LocalStack. And we achieve that by using a configuration management tool called Dynaconf, which allows to specify various settings. And in this case, we are specifying the default for the AWS endpoint URL to an empty string. And during development, we pointed to localhost.localstack.cloud. And that means that when we instantiate AWS client config, we read the endpoint URL from our settings file, and we can be sure that during production, it will connect to AWS, while during development, it will connect to LocalStack. Cool. But that's not all, right? So that's just achieving that we can connect to DynamoDB, for example, from the Flask application. What else is there? Well, there's lots of lambdas, as you've seen, right? There's lots of ECS there, there's EC2 serverless resources. And for that, we're using CDK in production. So our whole backend is built with CDK in mind, which allows us to deploy our application to production. And we are also able to deploy everything to LocalStack during development times. And on the left-hand side, you can see I've included two screenshots. The first one is a make target called deploy local, which uses CDK local to deploy the whole stack to LocalStack. And on the second screenshot, you can see that it takes little amount of time, almost a minute, to deploy the whole application locally, which is great because once everything is deployed and wired up correctly, we can write and run integration tests. So for this example, I have included the sign-up flow, which typically includes the API response. It includes persisting an entity incognito, and it also includes sending of a mail to confirm the account creation. So on the right-hand side, you can see a small example, which first uses requests, a Python library to post a request to the sign-up endpoint. Then we check whether the response is successful and whether the ID is not none. Then we fetch, or we try to fetch a user from Cognito with that email and assert that it's not none. And last but not least, we list messages of the SMTP server and verify whether the subject reads LocalStack account activation. And with these three steps, or two steps rather, so first pointing Boto3 to LocalStack and also deploying everything to LocalStack, this is made very easy because it's just plug and play. You can click on run the test and it connects to your locally running instance and can verify whether all of these assertions hold. For the concrete development and debugging, we make use of two very exciting and cool features. So one of them is Lambda hot reloading, which I tried to depict on the right-hand side, which basically mounts files of your editor, in this case it's PyCharm, into an S3 bucket that then lambdas run from. And on the left-hand side, I've included the code snippet that's needed to enable that. It's really small. First of all, we have to create a bucket called hot reload, and then we create lambdas from that bucket. And every time we change a function code or we want to change the implementation, we do not have to redeploy the whole application, but it's automatically reloaded because of this hot reloading feature. Similarly, we have the same for ECS tasks. There's a bit more complicated, but still pretty easy. We create volumes, or just one volume, which mounts the project into the container. And hence, whenever we make changes to files on the file system, the container reads from the same files and hence can just respond with the new responses. But there's more. LocalStack extensions, for example. We use them with the auto install feature. That's started with extension _auto _install. And we use both the Mailhawk and Stripe extensions, quite extensively so, because they allow us to test purchasing flows and also mail flows. So in the previous example, you saw me make asserts against the mail server. So that's where Mailhawk comes in. And it basically allows us to fetch any mails that were sent during the lifecycle of the application. And then also we have the Stripe extension, which just allows us to really test end-to-end flows of customers purchasing a subscription. So we can see whether it was persisted correctly on Stripe's end. And last but not least, for local dev and testing, we also make use of our cloud pods. So what we have in the backend repository on GitHub is an action that creates a pod on each push to main. And for those unfamiliar with pods, Pods basically take a snapshot of the state of LocalStack and persist it in our storage backend. So for our backend, for example, we take a snapshot of the state, which is the whole infrastructure that's deployed. And our front-end engineers can just pull that pod, deploy it onto LocalStack, and just focus on developing the UI. So they do not have to set up the repository for the backend on the machine. They don't have to install dependencies. They don't have to do anything. All they have to do is start LocalStack with the pod, and they can develop the UI against the backend that's already running on LocalStack. So without further ado, I would like to take you on a small demo of the locally deployed web application. So I deployed the application, both backend and frontend, onto LocalStack, and that's what you can see on my screen. It's served on app.platform localhost.localstack.cloud, and we can do basically everything that we can do in production as well. So I have my test account here called John Wick at LocalStack Cloud, and I can try to sign in. So for example, if I enter the wrong password, it tells me that we were unable to verify the credentials because that's the wrong password. But if I manage to enter the right one, I will be able to sign in. And for those of you familiar with the web application, this might look scarily familiar. So this is not production or staging or any other type of pre-production environment. This is all locally. And I can see the familiar dashboard. I can click through getting started. I can take a look at my local cloud pods. I can take a look at LocalStack desktop information and so on. Also features the resource browser, for example. So in this case, I could take a look at what's currently deployed on my LocalStack instance, sort of like Inception. And yeah, that's pretty cool, right? The whole application we've developed all on my machine. And what this allows us to do is be really fast, right? We don't have to wait for any deployments onto production for the backend to make changes. We can do all of that locally. With that said, let's jump back into the slides, and I'll give you a few more points for discussion. We also use LocalStack in the next stage of our lifecycle, which would be CI pipelines. So after developing a feature locally and writing tests locally, we push our commits, as many of you might do as well, to GitHub, where we have the repositories and where we make use of GitHub Actions to run the tests. So we make use of the LocalStack GitHub action there, which Harsh will talk more about later. We also use state snapshots with CloudPods during CI pipelines and also make use of the CI analytics feature. But more on that later. Please stay if you're interested in that. Harsh will do a presentation on that right after me. So stick with the talk and I'll move on to this next step in the software development lifecycle, which are acceptance and end-to-end tests. So typically when we have confidence that our new features work through the integration test suites, we want to make sure that this also hits the requirements, expectations of other stakeholders. So not from the technical perspective, but also from, I don't know, for example, sales. So by using ephemeral instances, which are short-lived LocalStack instances in the cloud, we can enable that. We basically create a publicly accessible instance of LocalStack and can then do two things with that. One of them is the application previews / acceptance tests, and the other are end-to-end tests. So for application previews, what we do is very elaborately put here. First, deploy the app onto the instance. So both the front end and the back end are deployed onto LocalStack. And then we can take the link that's created for this ephemeral instance and send it to coworkers or other stakeholders and be like, hey, I've got the feature you requested here. Take a look and let me know if that looks good to you or if you want something to be changed. On the right-hand side, you can see, for example, also a GitHub comment, which we use, which basically just adds the URL of the instance to send to someone else. And what this really allows us to do is to get sentiment from other stakeholders before shipping into production, which is really great because in the past, we were blocking a staging environment with it all of the time and got kind of this contested dev resource because everyone wanted to display something and deploy something. And with this, everyone gets basically their own staging environment. Last but not least, we have end-to-end tests. So similar to application previews or acceptance tests, we deploy the app onto ephemeral LocalStack instances, then run the end-to-end test suite that we have implemented with Playwright, and then we receive the results. So another nice use case for ephemeral instances. And for ephemeral instances, I have prepared another demo. So what I would like you to take a look at is this tab here. And you will have to trust me here or look at the URL. This was all locally, but this is on an ephemeral instance. So this is LocalStack running in the cloud, the front end and the back end deployed onto it. And just like locally, I can now log in with the right credentials. I see the web application and I can verify that the new features hold or satisfy requirements. So I don't know, I can be like, hey, I've updated the header on the recess browser, sent it 2 p.m. and get feedback whether that's all right or not before shipping it to production. What I can also test, for example, is sign up. So I can sign up with a new mail and choose a very hard password here. And that already exists. So let's add +1 to 3 to it. And I can see that signup works on the ephemeral instance. And funnily, since the Mailhawk extension is installed on the instance, I can also see that I just received a new mail, which asks me to activate my account. And in doing so, I can then log in. Cool. With that said, I think it's time to switch back to the slide. And I am actually at the end.